Yes, thank you so much. Now I'm just looking for the sign that we are starting to record. Thank you so much. My name is Monika Stankiewicz. I'm Executive Secretary of the Minamata Convention on Mercury, and I would like to welcome you to the event on socioeconomic impact of mercury pollution. I hope you are safe and well, and you are doing very well today. And I would like to welcome participants, but also panelists whom I have not have a chance to meet, but I have been really impressed by the work you have done, and I really appreciate that you have found time to join us today and present your work. This Minamata Online session is the digital series of virtual events initiated by the Secretariat of Minamata Convention with the idea that we would create a space to present and exchange on the various aspects of the Minamata Convention, and specifically on three streams, that is the convention implementation, review and support, preparations for the fourth conference of the parties in 2021, and an innovation from our side, which is on Mercury and science, with the idea to connect to the networks of researchers and scientists who do such a great job to support the convention processes and its implementation at various levels. And this specific Mercury and Science strand is co-organized by the Secretariat together with International Conference on Mercury as a Global Pollutant, the cooperation that is very much appreciated. And the aim is really to bridge the scientific community and international policy. And this specific session extends to social and economic sciences. I mentioned we have excellent panelists who will present today on their work on socioeconomic aspects of environmental pollution, and we will have a discussion on how social sciences can inform decision-making and in the context specifically of the Minamata Convention. Just for the record, I would like to mention that this event is being recorded. We will make the recording available on the convention website afterwards. And let me also mention that this session is the last of the 13 events that have been held since September within the 2020 of the Minamata Online. And I would like to take this opportunity and thank all the contributors, presenters, and participants, and my colleagues in the Secretariat for engaging in this initiative. Based on the feedback that we have been receiving from parties and other participants, the initiative can be considered a success, and we are working currently towards launching the 2020 season of the Minamata together with our partner and other partners. And the participants of today's event are also welcome to provide your feedback and suggestions and ideas regarding the content and format of future sessions. But let me stop here, and I'm really delighted to introduce our panelists for today. So we have Professor Jozef Pacyna from University of Science and Technology from Akademia Górniczo-Hutnicza from Krakow in Poland, who will be also moderating the panel discussion. We have Professor Leonardo Trasande, Director from the New York University Center for Investigation of Environmental Hazards. Dr. John Stenning, Head of Environment from Cambridge Econometrics, Dr. Milan Ščasný, Senior Lecturer from the Charles University Environment Center and Institute of Economic Studies from Czech Republic, and Dr. Myriam Tobollik, Scientist from the German Environment Agency. Thank you so much again for being with us. I'm looking forward to listening to your presentations, and I will be joining you for the panel discussion. But now let me hand over to you, Jozef. Thank you so much.
Thank you very much, Monika. Good afternoon, ladies and gentlemen. I'm happy to present to you a presentation which can be considered as a kind of introduction to the topic of our session today. May I have my slides, please? Right. So, integrated assessment of the problem of pollution and impacts on pollution on the environment and human health would include the aspects of economy and environment due to the consequences that we have, the economic consequences and environmental consequences. And the key issue here is to obtain the as accurate as and complete as possible information on the of pollution that our body is receiving through various pathways, various exposure pathways. And on the other side is a question of to what extent our body would respond to this impact. Next slide, please. And my presentation then will be dealing with some general questions which are on the topic. And first of all, about advancement of research on assessing the dose-response relationship, the functions for Mercury and in the context of human welfare. Then on the other side, that's an environmental side. On the other side, there's a question of damage costs, which are relevant, in fact, for the current and future emissions. What would be then this damage costs in the future on the local, regional scale and global scale? I should say that I'm more environmental side, so then this part on the cost we left for the other fellow panelists. And finally, I would like to also see the issue of where are the regions when the damage costs would be sort of the major burden for populations, the cost, the regions, and also the populations, the people living in the areas. And finally, the question would be how may research on environmental and human health benefits support the implementation of Minamata Convention. We'll have this discussion probably after the whole presentations. Next slide, please. So this diagram shows the full chain of integrated assessment analysis, and in the blue colors would be the steps in the chain that will allow us to calculate, to estimate, to assess the major pathways that the pollution enter our body, mercury enter our body through ingestion of contaminated food, inhalation of contaminated air, as well as dermal contact, especially for kids. And it all starts obviously with emissions, with the processes that produce anthropogenic emissions, natural emissions. So this is a box in the green. So we started with the emissions to the atmosphere and water and land. Then there's the transport issues within the environment, with air masses, water currents, then the position to aquatic ecosystems, terrestrial ecosystems, and finally the process of metallation of mercury, because all of the emissions actually occur in the inorganic forms of mercury, which is not that toxic. The problem starts when inorganic mercury is getting methylated, and this occurs basically in the environment, not in the emissions. On the other side of the dose-response relationship, we have issues related to response of our body and assessment effects, health outcomes, and this is presented on this diagram in the yellow parts. Subclinical outcomes, morbidity, mortality, way of calculation, monetary, non-monetary, monetized issues, and so on. This we for sure covered much better by other panelists today. Next slide, please. So we all start with in terms of emissions, and then this is an example of global emission inventory that I presented. That was done for, in fact, presenting the scientific justification for establishing the Minamata Convention some time ago. So you see where are the emission sources. These emission maps will be then translated into or will be used to model the deposition maps and so on, concentration maps in various environments. All these activities and model activities are in fact related to just to see what is the dose of pollution. So then transport within the environment, then the transport within the food chain, eventually ending up in contaminated food and contaminated air. Next slide, please. And the important issue here is to see the major exposure sources then after the estimates of this transfer through this along this various steps of integrated assessment. So then the major source of metal mercury to our body would be a consumption of fish, different fish would be having different exposure. Obviously, the fish that contains less than 0.3 ppm seems to be the one which is safe, and some fish like sword, like American lobster and others, that would have probably some more actually concentrations, which could be a problem here. Then obviously another source of exposure could be eating the marine mammals, seafood. Then it's a question of consumption of animals which are nourished with fish, and also some issues related to the contamination of mercury in the rice. That may be also a way of exposure. Very interesting actually is part on inhalation of mercury, because I mean inhalation of air, mercury is an inorganic form. And so far we believe that this is not that important and for overall actually impacts. However, and in fact, in some areas, like in the urban areas or gold mining regions and so on, we inhale, or people inhale the inorganic forms, and inhalation occurs not in environment but in our body, inside, internal inhalation, methylation, I mean, of mercury. That is something which is really interesting, and there's recent work going in that direction. Next, please. Next slide, please. And the dose that we calculate or estimate with the given region, so on, would need to be compared with the reference dose. There are a lot of organizations, international organizations, that would deal with the assessment of the dose of pollution in terms of mercury that is sort of safe, in fact, would not cause major problems. This is like 0.1 microgram of mercury per 1 kilogram of human body per day. This would sort of be translated into the eating of 5 ounces of fish per week, fish that contain less than 0.3 ppm, and this is for calculated for a person 60 kilograms of weight. So you can see here the various organizations will propose different reference doses, but anyway, it's like between 1.1 and 0.4. Next slide, please. And then if the dose is in fact too high, then the reference dose, we need to go back, in fact, in the assessment chain and see what are the possibilities to reduce the exposure, the dose. And this is obviously the first thing we need to do is reduce the emissions. But the reduction of emissions and the reduction of exposure is not a linear. So in order to reduce let's say by 10–15% of dose that we receive, because it's too high than compared to reference dose, we would need to reduce more than 15% of emissions. And then the first thing you do, in fact, we see what is the need, how much you need to be reduced. Sometimes it's not necessary to remove every mercury from these industrial sources. And the other thing is to see what are already existing control equipment installations, in fact, in a given place that would need to be controlled, because a lot of desulfurization equipment, denitrification that takes SO2, NOx, even carbon capture and storage taking CO2, that would also take mercury anyway. So only after that we would then, after such analysis, we would need to see what might be the need for the add-on equipment and calculate the annualized investment costs and operating costs and so on. Next, please. And in this way, we end up with the dose that is sort of, by reducing the emissions, the dose that would be within the reference doses. On the other side, we have the issue of exposure effects. And this is actually why we really care about methylmercury, because it's in fact no toxicant that is causing loss of IQ, especially in kids. There's elevated cardiovascular diseases problem that occurs, immune system effects as well, other risks including. And also the issue of the transfer of mercury through our body with blood that easily penetrates through placenta and gets the fetus and the fetal brain. So there are various ways of exposure effects that we need to take into consideration when we calculate really the benefits of removing the mercury from the pollution. Next slide, please. Next slide, please. All right, this is an example from the work that we done some time ago, just for the convention that was in the report done for UNEP. And what you see here is the calculation of the damage cost through the ingestion issue, and this is calculated just for a loss of IQ, not cardiovascular and so on. Now the point is actually here that when we calculate the cost, the damage cost, in many countries there are no data, and very often we use the information from, for example, from US. And for that purpose, actually, we would need to use purchase power parity coefficient, because the dollar in US is different than dollar in another country. And then when we recalculate the damage cost with the purchase power parity, we see that, in fact, on the global scale at that time, the total cost damage cost was around 10 billion US dollars. Next, please. Just for the next slide, please. Just for the IQ loss alone, when we add to this, in fact, the cost for cardiovascular illness and so on, this the cost that was calculated should be higher, about 3 or 4 times at least. So then there's a damage cost on the global scale. This is again very sort of this has been very sort of preliminary estimates, simply just to see the order of cost and so on. And obviously the question was on the basis of emissions, emission maps of the position patterns, as well as global fishery data, where are the regions where the damage cost could be the highest? And then obviously we ended up with Southeast Asia, which is known for the high emissions from anthropogenic sources, South America, and a lot of impacts from artisanal gold mining, not only but also in South America, and obviously Australia and Oceania, because of the fishery patterns data that shows us in that direction. The damage cost could be reduced easily by using various strategies, measures, technology, non-technology, and so on. Next, please. Next slide, please. This is my last slide that shows that in the future there is a lot of work to be done. In fact, in the side of environmental assessments, there is a lot of development of modeling of emissions to the atmosphere, water, and land, modeling of transport, and this new dispersion models, migration models through the environment, through the various ecosystems in the environment, as well as modeling in the food chain. On the other hand, on the side of the socioeconomics, obviously there is work on improvement of monetary, non-monetary valuation techniques in assessment benefits and so on. Benefits here seen like a cost of damage avoidance. So then this will be also probably discussed later by the other panelists. And there is also the question of more accurate information for the dose response functions. That's always a pain when we like to relate the pollution to our human health, and a lot of information that is needed is often missing and is used from other countries and so on. We need to work more on the more advanced methods for exposure estimations, particularly in the food chain modeling in this connection, because ingestion of eating the contaminated food is the major source of mercury in our body. Then comes actually the issue of the methodologies that will sort of be more accurate to assess the future exposure, future emissions, and future doses of mercury. That's what we are working for the decrease of exposure to mercury in the future. We would need to see this issue in more quantitative way. And a couple of other issues here are the development of control equipment, the best available technologies, add-on equipment with all additives in place today that we have, bromine, chlorine additives to remove emissions of mercury from flue gases from industry, if the need is for that actually. Because again, sometimes it will be enough to have the existing installation for desulfurization, deidentification to take care about mercury as well as SO2 and NOx. And finally, there are also other methods, non-technological methods that belong to the group of best environmental practices. There's a list of measures in these issues to be to be developed, and this should be, in fact, enlarged in the future. Thank you very much for your attention. Thank you.
Thank you, Joseph. So now I would like to invite the next speaker, Professor Leo Trasande, and I was supposed to do the timekeeping, and I was trying to do this bell, but it seems that it doesn't work. So I'm going to ring the bell at 8 minutes. So
I'm sorry for later sort of
no.
A little longer introduction.
So I'm inviting Leo.
Good morning, and thank you to the organizers. I realize for many of you it's in the afternoon, so I apologize. But allow me to build on Jozef's comments, and as a pediatrician, just focus for a few minutes on the effects of prenatal methylmercury exposure on the developing brains of young children. So as Jozef described, mercury is emitted into the air, it deposits into water, microbes transfer the metallic mercury into form that's accumulated by fish on the food chain. Women eat that fish, and methylmercury essentially crosses the placenta, and the placenta is a sieve, and the fetal brain is a sink. And now we have multiple longitudinal birth cohort studies that have identified associations of prenatal exposure with decreases in cognition. Strongest in humans. Now,
Leo, I propose that you turn off your video because your voice is breaking. So perhaps it's your bandwidth. So
no problem.
Yeah, thank you.
I hope this is better. Thank you. So
Yes.
while not all the studies have shown the same relationship, it's fair to say that the U.S. National Academy of Sciences has reviewed the scientific evidence and had found strong evidence for fetal neurotoxicity of methylmercury. And it was based upon that assessment. Back in 2005, we proceeded to make the first estimates of fetal methylmercury neurotoxicity and the implications for lost economic productivity. To provide a bit of the translation, when a child loses 1 or 2 IQ points, the mother may not notice, the teacher may not notice, but if 100,000 children lose an IQ point, the entire economy notices. We know that each IQ point is roughly worth 2% of a child's lifetime economic productivity. And if on average, let's use an American child as the grounding for this exercise, this thought exercise, that child on average makes $1 million over his or her lifetime. Each IQ point is roughly worth $20,000 US. Now, as Jozef described, in different country contexts, one has to translate that using purchasing power parity or other corrections. But suffice it to say that the economic toll of mercury pollution as a result of children who don't apparently show the effects directly is substantial. And we found that $8.7 billion in lifetime economic productivity were lost in the children born in 2000 as a result of methylmercury exposure. And that was published in Environmental Health Perspectives back in 2005. Subsequently, I'd also identified that coal-fired power plants in the United States were directly attributable to $1.3 billion in those costs. Now, it's fair to say that there remains, as Jozef said, debate about the form of the function, the relationship of methylmercury exposure with loss of IQ. The $8.7 billion estimate is based on a logarithmic relationship. the folks at the U.S. Environmental Protection Agency have really stuck to a, I would argue, antiquated linear pedagogy, with the dose being the only thing, the proverbial poison. And there was a subsequent reanalysis of our work that modified estimates based upon a meta-analysis using that linear pedagogy. And I say that because we've now seen for a variety of synthetic chemical exposures that the dose is not the only thing that makes the poison, and nonlinear forms of the exposure response function have been found for a host of other chemical exposures. And so these nonlinear relationships are highly relevant. We also found that methylmercury exposure in utero, when you reduce IQ, you increase the number of children who are intellectually disabled. And in subsequent estimates, we identified the societal costs, not just in the United States, but in Europe, of prenatal methylmercury exposure in the form not only of lost economic productivity in clinically normal children, but then also in children who are shifted below 70 IQ, which is the typical cut point for intellectual disability. We've also extended these analyses more broadly across the globe. In collaboration with IPEN, we worked to leverage local data representative of local populations where there are highly exposed subgroups due to proximity to a variety of mercury emission sources, and quantified not only the costs in the form of lost economic productivity, but the loss in disability adjusted life years due to mercury contamination in those subpopulations. And as Jozef alluded to, the costs on face appear small, more in the hundreds of millions of dollars, but they are based upon very small subpopulations, first of all, and we have to be cognizant that as a proportion of each locality or country's economic productivity, those percentages are quite substantial and speak to the substantial potential gains, especially in countries that are disproportionately exposed, of steps taken to prevent fetal methylmercury toxicity. And that also represents a subset of the overall social costs of prenatal methylmercury exposure, in that emerging evidence also suggests that fetal exposure can produce autonomic instability, producing cardiovascular consequences, which I would say remain less than well understood, in the way that they probably are one of the understudied subfields of methylmercury or mercury pollution and its effects on the human population. So with that, I'll pause there to keep us on time and look forward to your comments and questions. Thank you again.
Thank you. Isaku, could you?
Sorry, I was muted. Sorry about this. So I'd like then to invite the next speaker, Dr. John Stenning. John, the floor is yours.
Hi, thank you very much. So actually, this is quite timely. Building on some of the things that Leo talked about in terms of what I want to talk about is going beyond the sort of the direct costs of on human health, and talk about how we capture the kind of second order and beyond effects of environmental and industrial policy in macroeconomic models. So this is where my expertise is. I'm a macroeconomist, and we do a lot of modeling of policy impacts. So that's what I'll be talking to today. Next slide, please. And the first question really is, how do we assess the impacts of policy? And there are sort of two prevalent sort of schools or ways of doing this. So the first is what we call a multi-criteria analysis. This is the kind of work done by, for example, the European Commission in their policy impact assessments. And what this does is essentially it tries to evaluate a wide range of impacts, of policy impacts, across a number of different indicators, a number of different strata. And you've got a kind of example here on the right of a piece of work we did for the World Resources Institute, where you can evaluate a number of different metrics, a number of different sort of topics, so you can keep separate, for example, economic impacts from health impacts, and you can independently measure those. What it struggles to do is to sort of combine everything into a single metric. It's very difficult to weigh up the different costs and benefits when we're adopting these kinds of approaches. The alternative is the kind of cost-benefit analysis approach. This is, for example, what is used by the UK Treasury. I mean, it's used by a lot of treasuries sort of across the globe, and it's essentially trying to monetize all of these costs and benefits to bring them into the same set of units, so that you can essentially stack everything up. You know, add up all the benefits, add up all the costs, take one away from the other, and then you've got a net benefit or a net cost. And you know, the obvious benefit this has is it's directly tractable. You can immediately it gives you a single number, and you can say something with that final number. Of course, the challenge is, well, is money really the best way to measure everything? I think we'd probably all agree that, you know, money isn't the best way to measure all of these health impacts necessarily. It's a kind of necessary evil, if you like, in this kind of approach. So that's what we're trying to inform here with the use of macro models, is these different types of policy evaluations. Next slide, please. And when we think about capturing health effects in macroeconomic models, there are four major areas that we look at. The first is the healthcare costs. Essentially, these affect the bottom line, if you like. So bottom line of governments, if we're talking about state-provided healthcare services. The bottom line of consumers, if we're talking about private insurance or individual payment healthcare systems. There's an impact on mortality rates. Essentially, as we're able to avoid health damages, people are able to live for longer on average. That changes the population, which impacts obviously upon the availability of labour in the economy, and also the overall level of spending, the level of consumption in the economy. More people obviously equaling more consumption. And then on the labour market side, we see two major effects. One is around labour market participation. Essentially, if you're avoiding illness, then people can participate more in the labour market. They can essentially, you know, you lose fewer days to ill health. And also, of course, there's this sort of the additional benefit there of avoiding potential benefit payments from the state where those exist. And there are labour productivity effects. So actually, it's not just about taking part in work more, but it's being more productive when at work. We see strong labour productivity effects. So these are the four kind of effects that can be measured. And exactly how they're represented in models varies from modelling framework to modelling framework. There are different types of models that capture these different effects sort of better and less well. In the next slides, I'll talk about one particular example. If we go to the next slide, please. Which is how these are represented in E3ME. This is Cambridge Econometrics' macroeconometric model, and is a good example of how these impacts can be assessed and the kind of impacts they have ultimately on the economy as a whole. So the reduction in healthcare costs that I talked about, again, this comes back to some extent down to who pays for the healthcare, but ultimately consumers are paying through one mechanism or another. You know, they're paying directly, or they're paying for it through taxes if it's a public run service. So essentially, what we see from positive health impacts is a reduction in healthcare costs, and therefore a shift in spending by consumers or by the state away from healthcare and towards other goods and services. And the impact of this on sort of GDP varies depending upon essentially how much of different sectors that are imported or exported. So if healthcare is mostly provided domestically, but actually we're shifting away from healthcare consumption and towards buying imported goods, for example, it can have a negative impact on GDP. In terms of mortality rates, so a reduction in mortality rates from improved health outcomes leads to higher levels of spending in the economy, essentially because people are around to spend money than they wouldn't otherwise have been doing. So that clearly has a sort of stimulus effect, a positive GDP impact. If we go to the next slide. And the reduction in mortality rates also has some interesting dynamics in the labour market. So we're essentially increasing the pool of available labour. What that leads to in the long run, at least, is ultimately lower wage rates and lower business costs. So at first glance, this can lead to, the sort of the short-term impacts here can be sort of to depress GDP. Lower wage rates means lower consumption in the economy. However, what we do see from those lower costs faced by businesses is actually improved competitiveness of industry. And ultimately that effect tends to outweigh any sort of loss of wages in the short term. So typically a positive impact on GDP there. Very similar effects from increase in labour participation, the same kind of effect. And then finally, labour productivity. So again, the competitiveness effects are very strong here. So improved labour productivity essentially reduces the unit costs of output, meaning we get positive benefits, improvement in international trade position, higher exports, therefore higher domestic spending, and typically positive effects, although this can be balanced out a little bit by low investment. Essentially, we don't need to invest as much in new capital because the labour we have is more productive. Next slide, please. So that kind of summarizes those impacts that we see. And so just to conclude, what I've shown sort of in a very brief example there, the macroeconomic models that we have and that we use are well designed for estimating sort of economic impacts of policy, impacts on GDP and employment. They're typically less well suited to measuring some of these health impacts. So really this is a bit of a thought exercise in, well, how can we ensure that the sort of the wider economic impacts of these measures are captured, and we move the discussion beyond sort of avoided damages to the kind of thing Leo was talking about overall impact on the economy and on productivity in the economy. And I think economic models, despite sort of the uncertainty and despite the shortcomings in sort of trying to represent a very complex system with very complex interactions, I think these models do provide a sort of improved understanding of wider benefits of improving public health through these kinds of interventions, and they help us again to compare the cost of policy implementation. And I think there is a role for these kinds of wider economic assessments alongside the sort of the damage costs of avoided type calculations that are very prevalent, and they should form part of a broad evaluation of policy impacts of these kinds of measures. I'll finish there. Thanks.
All right. I guess Isaku? I think we have some problem connections, probably. The next presentation will be given by Dr. Milan Ščasný. Milan?
Yes, thank you, Jozef. Yeah, thanks for my slide. So compared to Jon's very nice presentation, I will go one step back. So actually, I'm going to describe how to value health impacts or how to derive health benefits. So next one, please. So damages are quantified using impact pathway analysis. So it basically means that we start with measurement of emissions, then we model how these pollutants are transported in the environment, how they react together, and how these primary and secondary pollutants affect different receptors, including us, people. So maybe this diagram is a bit simple. It describes impact pathway analysis for air quality, maybe for ingestion and inhalation. It's more relevant for heavy metals, including mercury. It's more complex. But what is common for this analysis for impact assessment, that at the end of this chain, we have a monetary valuation. So we need to find a method or approach how to attain money or monetary units on the physical impacts, including health impacts. Next one, please. So if you like to perform this analysis, we need to have a reliable dose response functions or exposure response function, as Jozef mentioned earlier. And typically there are these three groups of health impacts attributable to mercury, and I just also taken these from Jozef's presentation. So first are the impacts on cardiovascular disease that ends likely with premature death, then reproductive outcomes and neurological and development effects, including the effect on IQ that Leo was also talking about. And usually and most often the effects on changes in IQ coefficients has been quantified by loss of earnings. Next one. But loss of earnings, it's not whole story. You can see here what are basically components of total economic costs of pollution reduction or pollution itself. So please remember that this WTP acronym is used to describe willingness to pay. So willingness to pay, it's comprises these four components. Loss of productivity or loss of earnings is one of them. But if we get sick, then some system or health system need to spend some money to treat us. So there are medical treatment costs. Now we need to pay something from our own pockets. So these are averting expenditures. So, and these three components are just present cause of illness. This is quite a well-known approach to you. But it's not everything. Then at the end, we have the fourth component, that is the value of disutility and discomfort of illness. Basically, if we suffer, if there is a pain and other inconveniences associated to different kind of illness, we are just not happy, you know. And this last components is sometimes one order of magnitude larger than the sum of the previous three. So it's not negligible impacts, and it's important to capture or quantify also value of this utility or value of discomfort. Actually, what Jon was presenting, it's measured by first three components: loss of earnings, or let's say effects on labor market, and expenditures of health sector. But we should highlight in our analysis made by ISRIMI model or others that this utility is not captured. Next one, please. So it's more tricky to value effects on premature mortality. So in the previous presentation, you saw that that dead man doesn't consume, right? And a dead man doesn't spend money. And so this is a way how this is captured in a macroeconomic model. So it's consistent with national account and it's correct. But if you like to quantify welfare impacts, then we need to get a value, or let's say willingness to pay, or how much we are willing to pay for reducing risk of dying. So this basically describes what is the value of statistical life that is then used in cost-benefit analysis. So this approach and these metrics has been widely used by many governmental agencies for policy analysis, including US EPA or various DGs, OECD, and others. And there is also increasing literature that estimated value of statistical life for various contexts, and even there are a couple of meta-reviews and meta-analysis that try to provide like central value of this estimate that can be used then in cost-benefit analysis. Next one, please. So if we quantify effects on health, then there are actually two approaches how to value them using individual preferences. So one, it's based on quality of life indices like QALYs or DALYs that is then used in global burden disease that you will see later, I think used in presentation or studied by Myriam. And these metrics have been widely used in cost effectiveness analysis, but this approach cannot provide information about the benefits. So if you like to quantify benefits and compare them with the costs, then you need to transfer health impact in the physical term or number of new cases of cancer and similar. You need to express these impacts in money. So both of these approaches are justified as a measure of individual preferences, but they approach and use individual preferences a bit differently. And both of these measures are used for different purposes. Both are useful, but used differently. Next one, please. Please skip this one. Next one. So as I said, there are a couple of health impacts attributable to heavy metals and mercury in particular, and one is IQ loss. So, and IQ loss is linked with other difficulties like cognitive difficulties, reduced school attendance, and if you just continue with this chain, you just end up with lower earnings. And this is actually the approach how damage attributable to IQ loss has been quantified. So there are many studies, including Leo's. Then you need to quantify what are expected earnings over one's lifetime, and then you have a value you would like to use further in the analysis. But as I said, this is not the whole story, and there are other components of total economic value. So there is one review that was done by Stavros Georgiou that reviews this literature, and it's a part of SVASHE project. I will be mentioning several times this project. It's coordinated by OECD and ECA. And within this project, several new valuation studies will be performed. And one of these will be just to elicit preferences or willingness to pay for changes in IQ of parents' child. So if you are interested in this research, I hope the first preliminary results will be ready by next summer.
Milan, sorry, I mean, could you summarize within a couple of minutes or so, because the time is running out?
Oh, okay. In next slides, they will be available for you. You will see that there are a couple of results or estimates for childbirth, infertility, birth defects, and low birth weight. So this diagram just described that is more complex. You know, if there are chemicals, we can analyze the direct impacts on IQ or indirect impact mediated through birth weights. So I would like to only use these slides to highlight that there might be potential problem of double counting if we analyze health impacts or if we get a value for different health impacts. So please skip the next like 3 slides that you can read at home. That is just information. Next one, please. That is just a list of approaches to get a value for health outcomes attributable to mercury, including Meyer research. So as I said, it includes willingness to pay for increasing probability to conceive or birth defects, very low or low birth weight. There are reports published by ECA or Health Canada with this specific value. Please, if you can go to next slide and skip, I think, 2 of them. Yes, please skip it. because I'm running out of time. Next one. This is a table to document the value estimates on willingness to pay for different health outcomes for different countries. Next one. And next one. In the last 3 slides, I just would like to open another issue. So if there's a policy, usually you reduce not one pollutant, but several pollutants, right? And this analysis we just did for climate change mitigation policy. So through this policy, we are not only going to reduce greenhouse gases like CO2, but also air quality pollutants and heavy metals. And mercury is one of them. And you can see for typical policies, these estimates was done for RCP scenarios to reduce emissions in a power sector. So the damages attributable to mercury are relatively small. These are emissions. If you go to next slide, you will see external costs or avoided damages. So for Western countries and Eastern and Central European countries, for reference scenario and RCP 4.5 and RCP 2.6 that are associated or attributable to different pollutants. So it's important, but I would like just to summarize that it's important to provide whole this analysis, including different types of pollutants, not only address one pollutant if we are analyzing policies, for example, that affect power sector. And the last slide, it's just maybe some information to think about. We know that the impacts will appear not only in one country, but maybe in the globe, or at least in many countries. Then there is an issue or question on policymaker which damages or which impacts should be considered in a cost-benefit analysis. And if we consider damages that will appear in many countries, how to value them? Okay, so we just perform this analysis when we only consider impacts on Czechs, or if we also consider impacts on people that live in Europe or other regions, and if we assumed monetary value that Czechs would be paying, but we would be ready to pay, or if we assumed values that particular people living in different countries will be willing to pay. And you can get, of course, different results. So this is more like normative issue, but I think it's worth to discuss. Thank you for your attention. I really apologize for taking more time.
Milan, thank you very much for a very interesting presentation. We may go back to some of the issues at the time of the questions. So we have a presentation now by Dr. Myriam Tobollik from the German Environment Protection Agency, Umweltbundesamt. Myriam, the floor is yours, I would say.
Thank you very much. Yeah, I'm going to present you a study which we did some years ago. We quantified the global burden of disease due to mercury used in artisanal small-scale mining. Please, next slide. So our goal was to quantify the number of disability-adjusted life years, which you already heard the acronym DALI before in some of the presentations. I was very happy about that. Which are attributable to chronic mercury vapor intoxication, which I'm going to explain a little bit further in the next minutes, which is used due to mercury in artisanal small-scale mining. Just to be all on the same page, to know what exactly artisanal small-scale mining is, you have some pictures here on my slides. So it's really working with rudimental techniques. They work with the hands. In the middle picture, you see the mercury. So they touch us with the hands. And on the right-hand side, you see a person who is evaporating the mercury with the ore. So he's blowing with his mouth on the mercury, and the mercury vapors, and he inhales it then. So you see, it's very easy without safety techniques. And that's what I'm relying in my entire presentation. So I'm a little bit more focused like the other ones. And I would really like to be sensitive about this topic because it's a special exposure, which I'm going to talk about. The project was funded by the Pure Earth Institute and published in Annals of Global Health. So if you have more questions, you can definitely ask me or also look in the presentation and in the article. Please, next slide. So we used the burden of disease concept. Also a few words to this. It's using a summary measure of population health, which was developed by the World Health Organization in the 90s, together with the World Bank and the Harvard School of Public Health, to combine effects of mortality, which are displayed in the years of life lost due to premature mortality, and together with the morbidity effects, which are part of the years lived with a disability. It's by that combining both effects and being by this more holistic than looking only on death, because we are also living with a disease, and especially with chronic diseases. The best known example of the global burden of disease is the study done by the Institute for Health Metrics and Evaluation, which are just published a few weeks ago, their results. It's a huge source of information. I really love this source. I can really recommend everyone to have a look in this to see the exposure and the health effects of different risk factors. One very important thing is mercury intoxication due to artisanal small-scale mining is not included. So if we only look at these big studies, we are missing risk factors. We are missing very, very important risk factors. And that was why we did the study, which I'm going to present you now. So please, next slide. So coming now to the methods. What was our population and geographical area? We thought, take the whole world. Let's see what's going on in every country where they are using artisanal small-scale gold mining. We didn't separate it for male or female, so we included all, as well as all ages. The health outcome is moderate cases of chronic metallic mercury vapor intoxication. You have a definition here in the blue box. So it's persons with a high level of mercury in his or her body causing a slight tremor of fingers. So it's a shifting, and the hands and the limbs, erotism. So it's something that the brain is not really working as it was working before. Like they are more tired, they have problems in sleeping. So it really affects their entire life. And also it is that there is an increased excretion of proteins in urine. So it also has a function on the renal effects. So this is the health outcome we were looking, and we quantified it, like I said on the previous slide, in terms of DALYs. But because we don't assume that you directly die due to mercury vapor intoxication, it's rather really a chronic effect. That's why we only quantified YLDs, and this we done by the prevalence-based approach, because for other approaches we were just missing data. And how we do this, or how we did it, was we have the number of miners multiplying with the prevalence rate of mercury vapor intoxication and a disability rate. And I will come now to the details in the next slides. So please, next. The number of miners. In the beginning we thought, okay, come on, this should be an easy number to get. No way, it is really, really difficult to get a reliable number of miners for each country, because there's nothing like a register or something like official data on that, because mostly it is an informal and in some countries even illegal work, as well as it is that many people have a normal job, but because they don't earn enough money, for example, they go to the mining area just a few days per week. So, for example, if they're having a fast in some days and they need money, they just go to the mining areas and work there to get some gold, for example, to afford a birthday cake. So it's really difficult to get numbers on this as well. So what did we do? We checked for studies which already estimated, mostly it was also modeled, data, which was done by Thelma and Vega, and they observed in more than 70 countries that there's mining activities. And then there was another study by Secatore. They presented the number of miners for 56 countries on the world. And we did an additionally search, and we found another numbers for 6 countries. Out of these, we got numbers for the miners, like a minimum and a maximum number, because there are huge differences in the number of miners, because like I said, it's mostly modeled, and we used both to show the uncertainties. Next slide, please. So the next factor which we need to quantify the DALYs is the disability rate. A disability rate is a factor for the severity of a disease on a scale from 0 to 1. 0 is a state where you have no negative health effects, so you're totally healthy. And 1 is a health effect which is comparable to death, so it's really bad. So, and the disability rate which we are using for mercury intoxication is 0.368, which is estimated in a study. It is based on the UQUL, which is a generic.
Hello?
Mercury intoxication. So the person has no problems in walking, but for example, has some problems with self-care, like I said before, because there will be mental problems related to mercury intoxications. And also have moderate anxiety or depression. So next slide, please. The prevalence rate, so how many people actually, or how many miners actually have the intoxication, was the most difficult number to get. So there we have huge uncertainties because we just don't know how many people really suffer from the mercury intoxication. So what did we do? We have from some studies the mercury concentration in the urine, and we have a medical score. Together, these data are used to give the number of people who are intoxicated. So this, I would say, medical estimation tool is even used by the WHO, and it was developed by Trash et al. And it is so far nearly the only tool which is out there and also recommended by institutions. We had data in this detailed format from only 5 countries: Ecuador, Indonesia, Philippines, Tanzania, and Zimbabwe. And that's, we said that's not enough. So we had a detailed look in the data. Please, next slide. Okay, sorry, there you can, I showed you again pictures just to see how the medical score is assessed. So you do some physical tests to see if you, for example, have a tremor or if your hands are shaking. So if you're putting your finger in front of your nose, a medical person can see if you're shivering, for example. Or with a teeth, you can see if it's blurred. So if you have too much mercury in your body, you can see it around your teeth, actually. Next slide. Here you can see the results of the prevalence rate, which we estimated for the project, and which we combined with other human biomonitoring data to have a bigger number of people who are actually having intoxication. But like I said, it's very, very an uncertain number, and we just estimated 2 numbers for the entire world, which is based, like I said, just on a couple of studies, because we are missing these data. We definitely need more data on how many people actually are suffering from mercury intoxication to artisanal small-scale mining. So the overall prevalence rate is 23.7%. And we also made a more specific scenario because we had specific data on people really working with mercury. So in artisanal small-scale mining, we also have people who are working rather like digging holes or going underground, so they don't have so much contact with mercury. So for sure, they don't have so much mercury in the urine. So we have a more specific prevalence rate as well. Next slide. Now coming to the results. The number of minors ranged from 14 to 90 million in 62 countries. So you already see here a quite big range, like I said, because of its kindly modeled data, and there are many uncertainties already in this number.
Myriam, could you please use 1 or 2 minutes more,
yes,
just to summarize?
Thank you very much. Yeah. Like I said, the prevalence rate was estimated from just a few individuals, and we just got the prevalence rate for the entire world out of the a little bit more than 3,000 individuals. Here you see also in the last 2 bullet points the results. So we quantified 2.2 million deaths, which is the minimum number, and we at the highest number we estimated 3.9 million deaths due to artisanal small-scale mining and mercury intoxication. Like I said, huge differences in the two numbers because of the uncertainties. Nevertheless, we quantified it. So we could show that there's an enormous burden due to this only this use of mercury. So it's only part of the big picture. Next slide. So I'm not going in detail, it just should show you that it is very unequally distributed around the world. So in the African region, for sure, the burden is much higher because their artisanal small-scale mining is a more important factor of income. Next slide. Here you see the world map where we showed which countries we included and the absolute number of deaths attributable to small-scale mining and mercury intoxication. And because of absolute numbers, for sure, the countries with the most inhabitants have the highest burden. So, but just to give you an overview. So now I promise the last slide. So it's just a first very short discussion. There are many uncertainties which I cannot put enough emphasis on it. Nevertheless, it is a very important result because we need to pay more attention to the burden of these people, because if we just look at these big studies which give us an overview, we are missing this. So there is a huge health burden, and to better quantify it, we need more numbers. We need more numbers on nearly everything. How many people are working there? How are the health conditions of these people? And the prevalence rates. We need registers. So yeah, that's I want to end with this. We need more numbers. Thank you very much for your attention.
Thank you very much, Myriam. That was very interesting presentation about the problems with mercury from the source, which is considered to be the largest anthropogenic source today, artisanal gold mining and production. Thank you very much. Now, we've been through the presentations, and we see how wide is, in fact, the subject of socioeconomics in relation to pollution, in relation to mercury. And this is a time that we have now, 20 minutes, for some discussions. First is for discussion between ourselves, and then, if time allows, for some questions that were probably identified during our presentations. I'm not sure that we will have the time for the last portion of questions about from participants, but then if not, then we will sort of answer the questions by email. Now, I would like to start a discussion asking Monika. You've heard about what is this about the socioeconomics and so on for the mercury business. How do you see, Monika, the potential use of socioeconomic science in the future implementation of the Minamata Convention? That's a major question that I have to start with in the panel.
Thank you so much, Jozef, and thank you so much for the excellent presentation. I think we can, with our event, scratch the surface of the topic, but I'm very happy that we have had this opportunity really to kick off the start of consideration. And of course, our natural interest from secretariat side, from party side, is to understand how much research results there is to support the implementation of the convention also in the future. And social and economic analysis and science can be of use in implementing any multilateral environmental agreement, in fact, as much as natural science. However, I think that overall at the level of MEAs, multilateral environmental agreements, we tend to engage social and environmental economy experts and scientists less often. And this event, as I mentioned, is an opportunity to demonstrate relevance and usefulness of this research and results to the convention. And you, Jozef, on your last slide, you alluded a little bit into these future opportunities or how it can be used. Of course, this scientific support can be at different levels. So it can be at the level of local measures or level of the sector, like SGM. It is often used for national considerations and policies in the ratification processes of the Minamata Convention, but it can also potentially be useful when collaborating at the level of the convention and of the conference of the parties. And this economic analysis, what I also like about it is that it can look into the future. So often with the applied sciences, we try to chase the status of the environment, and it's always getting outdated very soon. So we always talk about the past, but the modeling and socioeconomic analysis can help to look into the future. I would like to briefly maybe provide the general references to the convention and where I see, based on the text of the convention, some social economic analysis or information could be of support. And overall, the convention has a quite comprehensive approach to what kind of information is to be sought after or used in the implementation. For example, there is an Article 22 on effectiveness evaluation, which requires a conference of the parties to evaluate the effectiveness of the convention on the basis of available scientific, environmental, technical, financial, and economic information. So the convention does foresee that also economic information could be included, and naturally, when implementing or when estimating cost of implementing measures, it's important to estimate their benefits and to do so in monetary terms. These benefits, economic benefits you mentioned in your presentation, then can be direct benefits to economy, but then they can also be with regard to human health. There has been an impressive examples of how it can be done, but also with regard to the environment. And here I would like to, without dwelling on it, refer to the point by John Stenning, whether it's necessary to monetize everything. Very interesting question, and I think different people would, depending on what they work and where they belong in society, give a different answer. And so it's what I'm learning now, that there's a lot of useful research with regards to benefits of implementing the convention and its measures to human exposure of metal mercury. It can provide some indication of the projected effectiveness of the convention, different levels, and what I would like to also appreciate is that this research can go even as far as to estimate the economic loss due to the loss of IQ and attribute it to a sector as presented by Leo Trasande, but also the burden of disease to mercury used in ASGM. And as you mentioned, Jozef, this is the single major use and source of mercury. For me, it would be interesting to learn, not necessarily now today, but in the future, if there are similar studies available, or if it's possible, based on the current data and knowledge, to estimate benefits of improved status of the environment with regards to mercury contamination. For example, there were some stated preference studies or willingness to pay studies for good status of commercial fish stocks, for good status of some aspects of biodiversity. So whether it's possible to apply the method presented by Milan Ščasný to benefits of healthy environment as such. And would you consider it important or possible? Are data there to really support such studies? Another article in the convention I would like to refer to is on reporting. So parties are required to report on measures they have taken, but also on their effectiveness. And this is not necessarily an easy task. neither for individual countries nor for the convention as a whole due to the lack of data. And again, environmental economy, science, and experts could be of help. In the future, also, as implementation of the convention advances over 5 years, a decade, or even a longer period of time, we may foresee the increasing need to know the cumulative effect of implemented measures and reduction potential of measures yet to be implemented by the convention. I know that for scientists, it might not be as exciting topic as it may be for policymakers. But still, this is something where I would think in the future there might be really used to have a structured approach and to be able to know where we stand in terms of achieving effect. And last article I would like to mention is on research, development and monitoring, which is a very rich article and which is about collaboration among parties on different aspects of inventories, modeling and assessments, including assessments of impacts of mercury on human health and the environment. And then it says, in addition to socioeconomic and cultural impacts. So social and economic and cultural impacts are explicitly recognized as a relevant topic for parties to collaborate on. And let me conclude that I am by no means an expert in socioeconomic impacts myself, and my contribution is really superficial and not an attempt to be really go in depth, which my fellow panelists have done so well. However, I would like to say that through my professional career, I came to really appreciate the socioeconomic expertise in science, move policy processes forward as a domain on its own, and also as a domain that is part of any interdisciplinary efforts to really do all kinds of assessment in support of the implementation. So I would like from my side to encourage the scientific community to continue research in this field and to do so taking into account the Minamata Convention and its evolving processes and its implementation. Thank you so much.
Thank you very much, Monika, for your enthusiastic view on the issues. We see clearly that you, as an executive secretary of the convention, see the major role, in fact, for the socioeconomic aspects in the assessment of the pollution burden, pollution problems related to mercury. Let you, in fact, furnish with more information from our panelists about how they see the future sort of work. What are the major gaps that we need to cover, and now in the near future, and the research? And please let me start with Professor Trasande, with the question of how you all see the major gaps, in fact, in the research on assessment of economic losses in connection with the contamination of environment by mercury. Major loss. Could you please summarize a little bit as you see where is the area to improvement, in fact, for the information on economic costs of for the policymakers and so on. Leo, could you comment on that?
Yes, thank you for the opportunity. So we have a number of data gaps, specifically in the baseline exposure, and particularly in low and middle income countries where there are likely to be disproportionate exposures. Many of the global assessments of economic impact of methylmercury take an approach that is based upon high-income country data on mercury exposure. I think that approach varies, but suffice it to say there are substantial data gaps in the biomonitoring domain that provide some issues with the foundation and the extrapolation to benefits. Then there are, in particular, substantial gaps in our understanding of the cardiovascular effects of mercury, both the prenatal as well as adult exposure, that would be informative to help quantify the economic costs of exposure. As cardiovascular disease is quite a costly condition, whether you take direct costs for care or long-term economic impacts in the form of reduced economic productivity, etc. So I would say that with regard to the modeling of benefits of environmental interventions, there remains, I can recall back in 2005 when we published our first cost estimates, a lot of debate about the timing of the benefit of mercury reduction in fish and in human exposure as a result, for example, of coal-fired power plant interventions. Some argued very vigorously that it would take 30 years for economic benefits to accrue. I find that hard to accept, simply because there are many reactive species of mercury that emit from coal-fired power plants, for example, that are the most active, and then we all know sediment accumulates iteratively and cumulatively over time. So it's really the most recent deposition that produces the most recent contamination in fish and other sources. So I'll stop there. There's still a lot of work to be done, I would acknowledge, but we do have enough evidence for action, and I think that's the most important point above all.
Thank you, Leo, for your summary. That's very interesting and showing the way forward to meet the gaps or close the gaps in the near future. The question to John Stenning, could you please comment on the merit in assessing how the macroeconomic modeling frameworks available can be adapted to better account for the health impacts? You mentioned, you presented the model, and then could you see the future for the possibility for improvement in the future of some of the procedures in your modeling that are important?
Yes, and I think the most important area for improvement here is on the what I would call the supply side, essentially the labour market representations. So economic models typically are very good at representing sort of demand flows, so changes in demand and how they filter through the economy. What these models, some of these modelling frameworks are less adept at is dealing with sort of supply side constraints, essentially, or and really when we're talking about health impacts, that's what we're really talking about, right? We're talking about changes in productivity, changes in the availability of labor, and understanding how first of all how these health impacts actually affect, for example, labor market participation, how they affect productivity, the kind of thing that Leo was just talking about, and then ensuring that if we can well represent those at the micro level, well, okay, and how do they aggregate up, and what impact do they have at the more aggregate level? Economics, and particularly economic modelling, is full of assumptions and simplifications that we make, and it's important here that we represent the nuances of these impacts as well as we can. And that could involve things like sort of using agent-based modelling to understand essentially how individual agents react better, rather than the sort of aggregated economy-wide metrics that we typically use.
Mm-hmm. Mm-hmm. Thank you very much for your intervention and your thoughts. Coming back to Milan, then you were presenting a very interesting talk, and there was a little bit of a short of time. Would you continue a little bit on the means of improvement of the methods for quantification of economic benefits of human health impacts due to implementation of various policies? Milan?
Yes, thank you, Jozef. So let me first just really highlight importance of valuation, because as I try to explain the labor impacts and costs attributable to health system are very often much lower than this utility. And if we don't have this value estimates, then we may miss quite a lot. And this is also my answer to Monika, that whether it's necessary to value everything. It's not necessary, but if we don't value it, then we implicitly assume that it's zero. So it's good, it's useful to have it, but I know that it's quite time-intensive, money-intensive research. So my second point, it's to time issues, what Leo actually raised. If I remember, when we collaborated with colleagues from University of Stuttgart, so with their fate models, many of these impacts were really long-term, because the chemicals, what I learned from them, have tendency to persist in the environment for a long time. And then there is an issue for economists, how to discount, what is a proper discount rate. how to basically weight benefits or damages over time. And there's another issue, how to even weight these impacts across people, because we know that, you know, for poor guy, additional dollar, it has much higher value than additional dollar of very rich guy. So there's another issue of weighting over time or across people. And what maybe I was missing in this discussion, it's how we economists or even psychologists can contribute to this research or to these policies. And maybe what might be useful really to look at the behavioral and lifestyle research, you know, how to change behavior, because sometimes many things can be changed with relatively low costs. So maybe these are my comments. Thank you.
Thank you very much. And I would like to go back to Myriam now. Myriam, you presented the information on the health-related problems, health problems related to artisanal gold mining. How would you, what should we comment, your comment on the improvement of information on the disease quantification related to mercury pollution due to artisanal gold mining? You started presenting this. Could you go a little bit in more details on that? Myriam, please.
Yes. You mean on the data which we are
yes.
which are needed to quantify? Yeah, so definitely we need to have more studies, and they're around the globe, because I said it's more than 60 countries in the world, but we only had good data, which means human biomonitoring data and data from medical staff really going to the people, doing the test with them, looking on the health symptoms from 5 countries. So there's a huge gap of data, and we need to have more representative data from all over the globe to really know how many people actually having mercury intoxication. Now we assume that around every 4th or 5th miner have it, but it can be kind of a different level in different countries. So we need to have this data, but this is for the miners and the workers. On the other hand, we also have the children and the families. I was not talking about this, but this is a very important topic, because artisanal, so small-scale mining, is mostly done next to their homes. So directly after the schools, the children are going to their family, checking what is mama, what is papa doing, standing next to them, inhaling the mercury vapor, and also becoming ill. So there's not only people really working with it, but also family members who are suffering. So the burden is even much, much bigger, and we need to have a broader picture on that. So numbers are super important, and I also see the point that if we don't put a number, often it falls, it's not on the list kind of, but it's so difficult to put numbers on everything. And I really would like to emphasize that we should also have a broad picture in mind. We also should have the health effects of people, which we not always can quantify.
Thank you. I have a question again, Myriam, to you about this issue of internal methylation business, because I mean, what is produced, emitted in terms of mercury during the process of artisanal gold mining production is elemental or oxidized mercury, right? So when we inhale this mercury, then this is so-called not very toxic mercury form, right? Inorganic. But then the methylation possibly occurs inside the body. Is that something you consider when health impact?
Yes.
Go ahead, please.
Yeah, so we consider that for sure. It was not really part of the study which I presented now, but in former studies it was definitely tested, and that's also why that's a study we did just last year, where we were in Zimbabwe and we were testing for mercury. So what we did there was taking urine, we took hair, we took different kind of blood samples to see how much of the external exposure then turn into an internal exposure, and how we can measure it. So definitely it's also taken into account, but yeah, that's not really my field of expertise. Yeah.
Thank you very much for your answer to this question. Now, a question to Aisaku. Aisaku, are you still there?
Yes, yes.
Yes. Did you receive any sort of burning questions from the audience other than panelists? So you would suggest to put in for our discussion, or shall we or the panelists agree that we should answer these questions from the participants on the email basis or something like that? Because the time is really running out now. We have a couple of minutes. Anyway, once again, do we have a question from the participants?
Well, thank you, Joseph, for asking this. And I think I would pick up two questions. One is about the ecological effect. Is there any effort or methodology to estimate the ecological impact in the economic or socio-economic terms? And the second question is about someone pointed out that behavioral science is important in addition to economics. So is there any research into behavioral science?
Behavioral, right.
Yes.
Again, we have a couple of minutes now. Would someone from the panelists like to take the floor and approach the answer to the questions?
Here's Milan. May I answer the first one?
Could you repeat the first question, Aisaku?
No, I know it. If I may, I can just.
Sure. Go ahead, please.
Yeah. So, as Monika Stankiewicz mentioned, stated preference studies might be also used to value the effects on environment, on basically how people perceive or value the effect on environment. Of course, it's not valuation by the environment itself, but it's a valuation of people changes that affect the environment. As far as I know, there was one study funded by Health Canada and was performed by industrial economics that try to value together health impacts and the impact on environment for chemicals. But in general, I think it's potentially used, and there are also methods used in extended project series. Thank you.
Thank you. In terms of behavioral sciences, I think the answer is yes. Of course, it is very important to see behavioral study. I mean, the results of behavioral studies in the context of pollution of the environment and impact on human health in terms of mercury. This was not covered by the presentations. However, as I understand from the organizers of the Minamata online sessions, there will be another set of sessions soon, and we may sort of consider to organize a session going towards this discussion. So that's probably be the best way of answering the question about the role of behavioral sciences in studying the pollution and the impacts and policies and so on. Okay, and this is a time now to say, to thank first of all the panelists for a very interesting presentations, very useful information that was presented, and I hope this will be useful for scientists that would sort of see us on the website, on our presentations and discussions. I'd like to thank you very much to Monika and Aisaku and Pak and other colleagues, Kishore, and for giving us the opportunity for such session. I have the feeling that even that this is session number 13, that the 13 was a lucky number and the session was successful, taking into account the body of presentation, the body of information that was presented here. With this, I would like to also thank all the participants who may have seen us and was listening to us. I hope you will be also satisfied with this session. And this gets me to the point to say thank you very much. And I'd like to suggest that we see each other sometime during the second phase of the Minamata online sessions sometime in 2021. So be safe, go around the COVID-19, all the viruses, keep healthy, and all the best, and a happy new year for you. Thank you.
And thank you to you, Jozef, as well. Thank you so much.
Thank you.
Thank you. Goodbye.
Bye.
Thanks.
Bye-bye.
Bye.
Goodbye.
Bye-bye.